Hello, and welcome to Introduction to Probability and Statistics from Data Science Curriculum. My name is Dmitry Soshnikov. I am Cloud Developer Advocate at Microsoft, and I'm also an Associate Professor in a couple of universities in Moscow where I teach. You already know that data science has strong mathematical foundations, and those mathematical foundations are probability and statistics. And in this video and in this lesson, we will cover some basics of this discipline. One of the most important concepts in probability is called random variable. And you can think about random variable as about variable which takes different values randomly. For example, we can associate random variable x with the rolling dice. And this rolling dice, depending on how we roll it, can take different values. For example, we can get 1, then we can get 3, then we can get 6, and then we can get some other values. And all those values we can record in a table, and that would be called a sample of that random variable. An interesting question is how values in the sample are distributed, so-called probability distribution of a random variable. In the case of a rolling dice, you will probably expect every value to be equally probable. And if we draw the histogram, it will indicate the distribution of this variable. You can see indeed that different numbers, they have pretty much equal number of appearances in our sample. This is called uniform distribution. And we can then compute some probabilistic values from this sample. For example, we can compute mean by adding all values together and dividing by the size of the sample, and variance, which represents how far those values are spread. So random variables which take random values is very important concept in probability, but in statistics we normally deal with a different type of random variables, which are samples drawn from larger population. So as an example, let's consider all baseball players on the planet. This is the huge set, and if we want to study them, we can draw some sample from this set. For example, we can take the data set of Major League Baseball players, and for those players we know some parameters. For example, we know heights of those players. And the interesting question is how well this sample would represent the whole population, and how the values would be distributed. Well, if you think about it, there is some kind of average height for a baseball player, and the further you get from this value, the less probable it is that the person of this height would be included in the team. For example, it's really improbable that really not a tall person would be a baseball player. So this represents so-called normal distribution. The further we go from the mean, the less is the probability that this value would be included. And in fact, this normal distribution is so important because many things in real life are normally distributed. So coming back to our question, we have the sample from the whole population, and we can compute the mean of this sample. But would this mean represent the mean of the whole population or not? In fact, we need a notion of confidence interval to understand how accurate this measure is. And the confidence interval is called confidence because it is different for different degrees of confidence. For example, suppose we want the confidence interval with the probability with the accuracy of 0.85, meaning that if we draw random samples, 100 random samples from the whole population, in 85% of the cases it would fall within this interval. And in our case, this interval would be 201.73 plus minus 0.94, and this 0.94 is the width of the confidence interval. And if we want the confidence interval with a higher certainty, for example 0.95, then the intervals would be wider because the error could be more. So there is a scientific proven methodology to calculate this confidence interval, and it is important because if we just take some values from the whole population, we need to understand how accurate those measurements are, and this can be done using confidence intervals. Another interesting point that statistics studies is called hypothesis testing. Let's again take the example of the baseball team. We can take this data and group all players by their role in the team and compute, for example, average height for those different roles. And you can see, for example, that first basemen are taller than second baseman. And it's interesting to ask the question, is it really always the case? Can we really prove that first basemen are always taller than second baseman? Or it is just statistical error? To do that, the easiest thing we can do, we can compare those confidence intervals for those different roles. And if we see that confidence intervals do not overlap, that probably will indicate that indeed our hypothesis is true. And if they do overlap, that means that we do not have statistical evidence that this hypothesis is true. So there are some other hypotheses like how data are distributed, does the mean value correspond to some predicted value, and so on. And in our lesson, you will see more examples, and you will see examples how you can actually calculate confidence intervals and how you can prove hypotheses given some real data. Another important question is correlation. Are two values related to each other? For example, for baseball players, is their height and weight related? You can probably expect that that is the case. The taller the person is, the more his weight is. But how this accurate is this relation? The easiest way to answer this question would be to plot a correlation diagram. You can just plot one value against the other using so-called scatter plot, and you will see that indeed in those dots you can see some relation. You can see some upcoming trend. But is there a mathematical way to calculate the strength of this relation? In fact, that can be done using correlation coefficient, and in this case it's 0.53. And because it's more than 1, it means that there is positive correlation between those two values. If it is negative, it means that there is negative correlation. When one value increases, another one decreases. And again, in this lesson, you will learn how to compute those correlation coefficients. So what are important takeaways from this lesson that you should make? For example, to answer a simple question, are all men taller than women? You need some mathematical theory behind it, because you cannot just measure average height of 10 of your friends and make conclusions. You need probably larger samples, and from the size of the sample you would get different confidence intervals, and you can make this conclusion with different confidence. Those things are very important to take into account in the data science, because you need to know how probable, how confident you are in the decisions you take from data. So that means that good data scientists would probably know probability and statistics well. And in this course, we will give you just a small grasp of this discipline. And if you want to learn further, there are many sources that you can follow to get more proficient in probability and statistics. With this, I suggest you to read the content that we have prepared for you. I hope you enjoyed, and we'll see you in next episodes.